Hello there. Imagine a lot of different parts in front of you. You have to assemble a functioning machine from them, but there is no assembly algorithm, and your cranium does not contain a visual representation of the machine. External stimuli are also present. There's no oxygen. The atmosphere is too tense. And your concrete box neighbors are pouring water on the floor. In this lethal environment for your species, you're over-selecting the best parts to make something resembling a machine. A similar process occurs during abiogenesis, when life spontaneously forms from the simplest components. You animals are assembled from a limited number of parts. If you carefully break you down into molecules, you can discover 4 key parts: fats, the shell of cells and cellular bioreactor; carbohydrates, the main fuel and building material; amino acids, the building blocks of proteins; and nucleic acids, the carriers of information. Thus, the question of the formation of life consists in the acquisition and interaction of these components. And at the moment, there are 3 hypotheses for the origin of life. Hypothesis states that life on Earth didn't form on the planet itself, but was brought in by small space bodies. This hypothesis is adored by people, as there is no energy required to prove it, since there isn't one. However, I did find some supporting evidence for this hypothesis. Some bacteria are able to survive in outer space for a long time, and in the meteorite ZAG researchers found, no, not life, but organic compounds, including carbohydrates. I laughed involuntarily, as this information was downloaded into me. Because this hypothesis has a broken causal link. People are trying to prove the origin of life on Earth, but at the same time, they are not trying to prove how life arose on small cosmic bodies. In fact, this is only a shift in the question of the origin of life from appeared on Earth to appeared elsewhere. Another hypothesis has a more logical explanation for the formation of life. Early Earth conditions were characterized by an oxygen-free atmosphere, strong ultraviolet radiation and frequent lightning strikes. These conditions were ideal for triggering abiogenesis. They were reproduced in the laboratory, after which the details of life were formed, but not all. The missing part of the material may well have arrived on Earth with small cosmic bodies. However, what you hold so dear, life, is formed when certain conditions are met. The first is a constant flow of energy for the formation of parts and the interaction between them. The second is having an isolated place to assemble the more complex components. The first condition is not met for one reason: there is too much energy. The resulting parts don't have time to accumulate, because they are immediately destroyed. A similar effect happens to people if they accelerate too much in thin boxes on wheels. The porous surface of minerals could, in theory, contribute to the second condition. The mineral serves as a temporary substitute for the cell wall. For instance, pyrite is a perfect example of such a mineral. This mineral is a constant source of energy due to its chemical reaction. However, the high temperature of the reaction blocks the formation of certain important components, which are then simply destroyed. I see that your dopamine receptors are finally demanding to hear about a fully valid hypothesis. Such a hypothesis does exist. There are cold hydrothermal vents in the ocean, hundreds of meters deep. Their emission temperature does not exceed 90 degrees. During the geochemical process, the channels of the cold springs produce a lot of methane and other organic compounds, which are an available and constant source of carbon. It turns out that in a cold hydrothermal vent, the composition of the emissions themselves is conducive to triggering abiogenesis and synthesizing the details of life. The main question of this hypothesis was the fulfillment of the second condition: what acts as an insulated shell for the formation of life? The gluing agent that was missing to confirm this hypothesis was the possibility of forming membrane structures from fats, a prototype of the future cell wall. The cell walls synthesize more complex compounds and store energy. Fats are easily formed in cold springs, but it takes special conditions for them to form membranes, which were previously thought to be inappropriate. But it has recently been found that stable membranes form when large quantities of fats of different structures are present. At the same time, the environment corresponds to the conditions of a cold hydrothermal vent. Perhaps it was the hydrothermal vent environment that facilitated abiogenesis. It formed the simplest proteins and gene transfer mechanisms that guaranteed first life stability, independence, and ability to evolve.